Let's do this, huh? Hey, welcome. It's me, John Park. Let me finish turning on the lights. It's John Park's workshop, happening right here from sort of rainy Southern California for Adafruit West. That's what I'll call myself here today. Welcome to everyone who is joining us in the Discord chat as well as over in YouTube. For some reason, Facebook doesn't seem to want to connect today, but I know that there have been some issues with that, and I can only imagine that most streaming video is being hit harder than ever before right now. So I imagine we'll have some issues. I'm checking out the Discord chat, in fact, and there's some supposition by C. Grover that YouTube is having buffering issues. Could be too many workers at home. 2.3 second latency to streamer. That's awesome for Twitch, says Mr. Certainly. All right. Oh, good, and it's getting better. I also wanted to say that I am not going to play a video contained inside of a window today, because that may have been what was causing some of my issues last week with losing video sync. And I didn't need to for any of the stuff I'm doing today, so that's good. Well, I want to say thank you for joining me. I know that you have many options of what to do with your time and things that you want to tune into, and I appreciate you coming by to check out the show here. Let's see, what have I got going on? I wanted to, first off, take a look at our jobs board. If you go to jobs.adafruit.com, you can check out the jobs board. And one of the things that you might be interested in is the resume posting section. This section here under the available for hire, it is free to use. You just need to create a login and you can post any skills that you have if you're looking to pick up some work. I know some people, depending on their work situations, might be looking for contract work or freelance work to pick up, or other remote work. And so you'll see here a bunch of different people showing off their skills over on jobs.adafruit.com. So if you are looking to pick up some extra work, I encourage you to go and have a look there and post your resume. Another announcement, we are not exactly sure what the timing is going to be on the next AdaBox. I know if you go to AdaBox at adafruit.com, adafruit.com/AdaBox, sorry, I have an eyelash that I'm going to spend the entire rest of this show trying to remove. I think I got it. No, I didn't. All right, I'll stop touching it. Stop touching your face, all right? So the next AdaBox, I know we have the countdown here saying it is going to be shipping in 17 days. That seems unlikely at this point. So either it is going to somehow get out there miraculously in the next 30 days or so. Otherwise, we're going to push it to where the AdaBox 16 normally would have been coming out. So we're not going to squeeze one in there. We'll just push that. If you've subscribed, you're still going to get that. It's just a matter of when. So wanted to let you know about that. Let's see, what else have we got? Oh, I wanted to mention the coupon code for today. So today's coupon code is what is roundly considered to be one of the most beautiful pairs of words in the English language. It is cellar door. That's right, cellar door. And I wanted to share that pleasing sounding set of words with you as your 10% off coupon for Adafruit. Now, you probably know that Adafruit has ceased shipping as of yesterday at 11 o'clock Eastern Time. So you may not be planning to place a bunch of orders right now, and I totally understand that. But if you do, it will ship at some point, and that is your coupon code. We'll also be, as we mentioned yesterday, we're going to be setting up things with DigiKey so that you'll be able to continue to order Adafruit stuff from the Adafruit shop with some sort of a link to DigiKey. We're not certain yet right now what that mechanism will look like exactly. But I will also, where did it go? I think I chucked the package, but I just got my, my order that I had sent out kind of next day from my last order yesterday while they were still shipping before 11. Got some parts I needed for some projects, but going forward, I'll probably be ordering stuff directly from DigiKey, and I encourage you to go and check there. They have a great search engine in there and 50 bazillion different parts, but if you type in Adafruit, that's a pretty quick way to funnel it down with their filters. So that is your coupon code if you're using Adafruit Store. I don't have one for you for DigiKey, sorry. Since I have mentioned the store, I will mention a product of the week. And I checked, and in fact, this is something that you can get from DigiKey. I think there's a couple still in stock. Sorry, Todd asks over in the Discord chat, do discount codes work on DigiKey? No, sorry. I don't know, maybe bug them about that. What do you think, guys? Discount codes? Now I'm going to get them in trouble. My product pick of the week is this, the Octocam from Pimoroni. I have one, and I am finally planning to build it. Octocam is a Raspberry Pi Zero W, so it's the wireless Raspberry Pi Zero, the little itty-bitty Pi Zero, with a spy camera, which is quite a nice resolution and throughput. It's the direct camera connection on the board, so it runs pretty quick, throws a lot of data at there, extra pixel info. And they have this, on the Octocam, they have this really cute little suction cuppy PCB, I think it is, or maybe acrylic. I haven't even looked closely enough at this one. I'm going to open that later. That allows you to suction cup it to some glass. So if you want to have a camera on one of your windows facing out, sort of similar to the idea of like a doorbell cam, but entirely open source. They have some great instructions on Pimoroni's site, linked from the Adafruit page. In fact, let me open that up for you here. If you take a look, this is the Adafruit product page. There's 2 in stock at Adafruit, but then I think there are some more at DigiKey, or you could buy from Pimoroni. And if you check it out, there's a link here. I've passed it, tutorial on setting it up with Motion OS. So there's a, you'll put on an SD card, you'll burn an SD card, this Motion OS, which has been designed specifically for this purpose of using it as a webcam. And I'm not sure if that has motion detection or not. I haven't looked closely at it, but I do like the idea that it is a security cam, spy cam, doorbell cam type of thing that is not being run by a mega corporation and instead is open source. So you don't have to worry about who's scraping the data because it's yours to send to your own little server. So that's my project pick of the week. I'm looking forward to putting that together and playing with it. In fact, one of the reasons I remembered that I wanted to look at this project was a friend of mine, Todd Bott in the Discord, was talking about doing some Raspberry Pi Zero projects, and I thought, I'd like to do one. What do I have? And I have one of these. So that's my product pick of the week. All right, let's see. Gear report. I actually wanted to give an update. This is, I can use my overhead or my little down shooter camera here to show you this. So let me pull this camera out a little bit so you can see it and see if I can get it to focus. Stand by. I can't quite tell if that's in focus, but we'll find out. So gear report, I was working on, yeah, that looks pretty good. I was working on this Electrosmith voltage-controlled oscillator board, this little sub-module, as they call it. So I picked up this. This was like $25 from Electrosmith. They assemble fine synthesizer products in Southern California. And this is a voltage-controlled oscillator for making sounds that outputs different wave types, squares and saws and triangles, and pulse width modulation control for the square wave, a sine wave. And they make it as this little sub-module, and I decided to put it onto a Electrosmith. Mike Electrosmith sent me a nice faceplate because I was going to make my own sort of janky looking thing, but he sent me this lovely faceplate, so I decided to go ahead and screw in the knobs and potentiometers into that. And then I had to figure out, well, how the heck am I going to get these two things combined without making it miles deep? So I decided to sort of free dead bug solder a couple of sets of header pins. I'm not quite done yet, but I've been soldering up the connections for the pots and the switches, or I've got a switch coming, pots and inputs and outputs. And then I'm mating these two guys like this, and I have my power input there. And to save space, I kind of mounted it face to face like this instead of a more traditional back to back, so that I don't push things further out into the back of a case. So that's been coming along pretty nicely. And that was my progress report on my gear here, which is this 3340 chip-based oscillator. There you go. That's my gear report. Synthesizers are a good thing to be playing with at a time like this, I feel. Building them, tuning them up, playing them, making music, making fun sounds. I enjoy that. Hopefully I'll get that built before long, and I'll be able to share some fun sounds with you. All right. So let's see, what else is happening here? This is a pretty good time to check out our Make Code Minute. What do you say? All right, so let me throw this background away there. All right, let me pull this up. What I wanted to talk about today in the Make Code Minute is using some comparisons to tell when a couple of different sensors are in different states. So what you can tell here is I have essentially 4 different states, and what I'm measuring are my light meter and my temperature sensor. And what I decided to do is set, this was actually a suggestion again from my daughter. She's been coming up with great ideas for me for projects. She said, how about a weather sensor? So essentially this will tell me if it's dark or light, and if it's cold or hot. And so then I can display different colors on the NeoPixel ring depending on those conditions. So what I have are these 4 different conditional statements. So I'm checking, and each of these is a pair of conditions that are being checked. So I'm first setting, the first condition is going to check if the light level is less than a certain value, which I'm calling the light target, and I've set that up here at a value of 90. And the temperature in Fahrenheit is less than my temperature target, which I set to 80 degrees. Then it's going to be yellow. And so the nice thing is here, right here in the simulator, if I expand this so you can see it nice and big, you'll see that we have a little virtual light sensor slider and temperature sensor slider. So as you can see, when it gets over 80 degrees and it's dark, I get a blue lighting set. If it's light out, it's going to be red. If the temperature goes below 80, it's going to be yellow. And if it's dark and below 80, it goes to, I think it's orange, but it looks kind of yellowy on here too. So this is something that you can apply to a lot of different things, not just the sensors on the board, but different combinations of button presses, and it could be more than just 2. You can extend these, they'll get wider and wider and wider. But if you look right inside of the logic section, we have all we need here, these if statements, which you can expand, and these comparisons, which you can stack multiples of these inside of each other. So you can see we can have comparisons going on. We can have these Booleans like and or going on. So these can get really big and really wide, but they're fantastic for building the logic to do things like compare a couple things and give you a state based on those comparisons. And so that is your MakeCode Minute. All right, let me get that MakeCode off my face. There we go. So let's see, the next thing I wanted to do, so I've got a couple of different projects going on right now that are in sort of two different states. One, I wanted to show you a little bit more detail on something we talked about last week, which is the plant or flower watering robot. And the basics of it start with the clue and the little bonsai add-on. So that bonsai add-on is just kind of screwed into the bottom there, and it breaks out a few pins and gives us a motor driver as well as a speaker, a sort of nice large speaker on there. And in fact, if I, let's see, is this battery dead? I bet it is. Let me power this by USB. If I power this up right now, just as a reminder, what we have going on is, this is the sort of basic version of the project. Let me go to the overhead with this. So you can see here in this simple version of the project, which Kattni is writing a guide up right now on the bonsai, so you'll be able to get all those details on this pretty soon. On this basic version of the project, what happens is the 3-volt and the pin 1 are being measured as analog read for resistance level. And so right now they're essentially at 100. I don't know why it's only saying 99. It's really close to 100 because I've wired them directly together, and it's a pretty short wire, so not too much resistance. If I remove this alligator clip, you'll see now it's sensing the percentage as 0, and it begins toggling the motor on and off. I don't have the motor plugged in, but you can see the little light there is lighting up at the bottom, and it's toggling this motor driver. If I hold my finger to it, you'll see I'm getting a resistance reading of 21%. If I hold the clip closer to my finger, I'll probably get, oh, I guess that was a little drier now. Getting more resistance. I'm going to lick my finger, which I shouldn't be telling people to do at a time like this, but now it's 66%. So I have this calibrated, I think, at 50%. So anything over 50% soil moisture is going to leave that motor off, and when it drops below that, it'll start pulsing the motor. What we have plugged into these normally are a couple of long nails and a couple of alligator clips. And so if we take a look over at the bench cam here, in fact, let me go over there and I'll set you up with a overhead view as well. What I did was I built this 3D printed flowering robot for a different project a few years ago. And get this mallet out of the way. I decided to update this for the modern era and the modern microcontrollers, and pull out the old guts, which were a larger microcontroller. I was using an Arduino Uno, and I had a motor driver on there, Adafruit motor board, which was turning a DC motor geared way down to tip over a little watering can, which was very cute and sort of a anachronistic way to do it. Now I've got the pump, and so what I wanted to do was show you how I have, with almost no modifications, updated this project. So if you, let's see if I can give you an overhead view. Can I still give you that one? There we go. So if you look here, I've got a couple of nails going into the soil, and I don't have power plugged into this right now, but I've got my clue, which I've got a cable getting hooked on something inside there. I've got the clue and the alligator clips, so I can go ahead and undo those. And then I've got a wire running down inside with the motor. I'm going to slide this sideways just so you can see it a little better. My legs are not attached on this bot because I wanted to be able to compact him down a little smaller for storage. And so in here I have a little flower pot with some soil. And you can see I've got my tubing coming up and out. And previously this held some larger electronics. Let me see if I can feed this board through to drop it to the other side without disconnecting things. There we go. And if I pull this little lid off, this is the part I'm going to redesign, just because this piece was built specifically for the motor that I had in there and fitting some other parts, some LEDs and things. And so what I'm going to do is redesign that just so that it has kind of like these, you'll see these standoffs on the bottom. That's what held the old motor system in place. I'm going to flip that around and make two small ones to attach this clue to so that it faces forward. And then previously I was holding my water in a little watering can, a little flower watering can. But now I'm going to actually have a use for all this space inside. What I did was I just hot glued down a solo cup, which I trimmed down a bit. And in there I can submerge this pump. So this is a little submersible DC pump. You can see here I've taken some tubing and I made a sort of hose clamp out of a zip tie, just so that we would have a nice secure connection there. And the water gets sucked in this end, and the impeller then drives it up and out and over. And so you'll be able to just simply refill this with water, set this down in, and then let it run. To give you a little closer look at the bot itself, it's got these 3 pretty hefty legs. These are hollow just because I wanted to print them faster, but you could definitely add some weight to those to give it a little more weight and stability. And you could also permanently connect or use magnets or do something with these connections. I just have it sitting on there on these 3 little posts. Now you can see this was kind of the design here was sort of a diesel punk type of aesthetic. Based on the work of my friend Barry McWilliams, who's an illustrator who created this whole universe around Rylon robotical flower delivery bots. And so I went with sort of an aesthetic of welded together panels. And these are actually the real seam lines of my 3D prints. And then to connect them, I friction welded them using a Dremel tool and small stubs of filament so that I could heat and melt across those seams to create little weld marks. And I even printed them in different orientations without worrying about it, that we'd have sort of mismatches because it fit the aesthetic nicely, I think. Originally, for some reason, I had made this eye pupil brown, and I didn't like it, so the other day I painted that black, and I like it a lot better. I'm not sure why I made it brown in the first place. So we got a lot of space in there. You could do more with it, but we didn't want to go crazy and add lighting or anything like this because it's meant to be sort of a Victorian era to 1920s, somewhere in that era. I forget the mythology exactly. So that is the update on that, and I'm putting together a guide. I'm going to include all of the 3D printable model files for this so that you can make your own. This foot, I think, is one of the bigger parts that prints pretty much as a single piece other than the little collar and leg connector here. Those are separate, and you can just glue those in place. They snap in pretty well if I remember. And I painted them. As you can tell, I did a lot of just using acrylic paint and some washes and things. This was probably white filament originally. Some of it was blue filament that you can see in there a little bit. So none of that mattered other than I think that sclera of the eye is the only thing that was left alone in its original color. Same here. This is a single piece. Actually, no, I lie. I think this 1, 2, 3 pieces here. And maybe I didn't glue that in. Does that come out? That's a little loose, but I can't remember if I... Yeah, I guess I just didn't... So we can turn that a little depending on our mood. That is single filament, and then I just painted those lines there. So look forward to that. I'm working on that guide, and I'll be able to, like I said, provide all of the different models and photos of the assembly so that you can follow that. And in fact, I wanted to actually make a plug for that book, because if you are at home with a 3D printer and you're looking for some projects to build, I just had one project in this. Let's see, let me open up Firefox. Here's the book. called 3D printing projects. And there are about a dozen or more projects in there, all kinds of interesting things. There's, if I remember, a couple of different robotics projects. There are some practical projects. There's a 3D printed electric screwdriver project in there, some animatronic eyes projects, and on and on. I think there was a pen holder that has a LED light up ring in it for displaying a really cool pen. So you can go and look for that. I've popped it up here on Amazon, but I think if you go to the Maker Shed, Make Magazine's Maker Shed, you can buy the PDF for it if you want to get it right away rather than wait for a book to be shipped. And that's where that came from. So look forward to that. And then the next thing I wanted to do is talk about my next project, which is going to have a couple of different versions. And so this was a idea my daughter brought to me, and she said, hey, I was just singing Happy Birthday over and over again while washing my hands, and I thought it actually would be pretty cool if you made a Circuit Playground Express into a timer. And so what I'm going to do is take a Circuit Playground Express as well as a Clue and make two different versions of some hand washing timers. So let's see, before we jump into that, I actually forgot. I wanted to show a game of the week, and thinking about MakeCode, which is how I'm going to do this version, made me remember that. So let's jump over for a second, not to Project Build, but let's go to the MakeCode Arcade Game of the Week. And I'm going to bring up my browser here again and share with you my MakeCode Arcade Game Pick of the Week, which is Hangman by Thay STG. And let's take a look at it. This is Hangman. I think this may be the original version. I made a slight modification, which I'll talk about. But here you can see it's your traditional Hangman game. You use the arrow keys to move around the keyboard to pick letters. So let's head over to E, for example, if I want to guess an E. And I don't know what word this is, and it's hard. I may fail, but we'll give it a shot. And now I'll press the A key or the A button, rather, on the controller, the virtual controller. And it says there's one E. All right, let's try an A. Uh-oh. Let's try an O. And how about an I? Okay, we have a bunch of I's. And as you can see, when I'm hitting wrong letters, it is taking out body parts and displaying them on the Hangman's gallows there. Let's try a T. S, okay. Boy, I don't know. How about a C? An M? Simage. All right, I'm going to take guesses. Anyone in the Discord or YouTube chat? Hey, Noah and Pedro, you guys are over there in the YouTube chat. Welcome. Simile? Do we think it's simile? I'm going to say it's simile. Oh, and that's what Andy Calloway guesses as well. Yeah, we win. Simile. Woo! All right, I'm about 1 for 10 on winning in this. So let's take a look at the game here for a second. This is really impressive. It's done entirely in blocks. And don't cheat and look at this array because it's all the possible words that are in the game. So you can see this was created as a huge, huge array, which I'm guessing the game's creator may have used JavaScript to enter that list because it'd be a little faster. But I encourage you to go and check out how it's created. It uses some pretty cool logic to do things such as figure out where the cursor is and snap it into place instead of free floating it. When you press the A button, it will either display a correctly guessed letter and has some logic for going through and figuring out if that letter exists in the letter and where and placing it properly. Or it'll draw one of the body parts. If we zoom in here, there's the head, for example. So you could go in and do things like adjust those graphics if you're interested. What I decided to do is I was forgetting which letters I had tested. So I wanted to add a little bit of code that would give me a X through or a slash through a letter I had tested. So you can see here, I'm just going to drop it into place in that same block for the button A press. And what I've added is I create a new sprite, and I'm just giving it a type of food, which won't actually matter. And then I'm setting that sprite to whatever the current pos X and pos Y position are. Pos X and pos Y are already being found in this function here. So once we've added that, if we go back and check out the game, now when I go and let's try an O, you can see now which letters you've tried out, and you won't be as likely to hit some repeats. I actually don't know what happens when you hit repeats. I lost. Wow, that was horrible. So that is a lot of fun. Really very well done game. I'm super impressed. So please go check out Hangman by Thay STG in the forum.makecode.com, in the arcade forum. That's usually where I go to check and find new games, and have a look. And I also mentioned actually at the bottom of that post I piped in and included a little screenshot. I actually did it slightly differently, but that's a screenshot of my, my edition of putting some slashes through your letters. And if you run through all the possible ones in there, you can always add more word lists. I'd say that would be another fun way to customize this. So you also, as you notice, you don't need a piece of hardware to do that. So you could play that on, for example, a Pi Gamer or a Pi Badge or a Meowbit. Is that the name of it? I think Meowbit. KittenBot Meowbit. There's a lot of hardware you can play these things on, but you can play it right inside the simulator. So if you are stuck at home without any particular piece of hardware, go and check out MakeCode Arcade to learn how to program some games or play some games that other people have made or modify them. And that is my arcade game pick of the week. All right. So thanks for that slight diversion into the game. I forgot I wanted to mention a game of the week. Looking over at the chats, one question I got, Jordy G in the YouTube chat asks, won't the nails corrode? You can use galvanized nails and they will not corrode, but they will still, they're conductive and they'll still give you a reading. So usually for these types of projects you want to use galvanized nails. If people know of other solutions to that, let me know. I don't know if a stainless steel nail, they're probably more expensive, but I think a stainless steel nail might work. I know we have some people in the chat who have experience with moisture sensors and things like that. So if anyone has ideas on that, let me know. Also looking at the chat, someone asked, Wolf220 asked, what does the food sprite type do? It actually doesn't do anything until you ask it to. So in MakeCode Arcade, there are, I think, 4 or 5 categories that you can tell a sprite to be within. And then if you want, you could have, for example, at the end of a game level, all of the enemy sprites disappear. And so you can do a destroy all sprites of kind and pick that kind. So it's a way to sort of group together like items and give you a taxonomy or categorization of things. So, but in this case, it's arbitrary, it's just it has to be something, and I didn't want to pick player because that felt weird. So there you go. Other questions? That's a good question. All right, so let's talk about the hand washing project. I'm going to go ahead and let me plug in this prototype I made. So on the Circuit Playground Express, I decided I wanted to make a timer based on my daughter's request and have it count down 20 seconds. So let's go to the overhead first, and I'll show you that. And let's pop me in there. So let's see. Let me pop a case top onto there because that'll help you see the LEDs. Okay, so I activated it, and you can see now it's counting down. First by turning the pixels purple, and then by going through and turning them blue. And so that's your notion of 20 seconds. and then at the end it flashes a few times to say stop. Oh, it's gone and started again. So this is the newest bit of code. Let's see if I might be too loud for it. I have set it right now to be loudness based. So I'm going to restart it. Okay, so I'm going to be very quiet, but here it is waiting, and now the idea is I want to activate it by clapping my hands. And so you can see it spins up 2 dials, and then it starts counting down. And I don't know how well you can hear. I'll bring the speaker down for a second. So that's a little tune that it's going to play, and my daughter asked, won't that be annoying? So I decided, oh yeah, you're probably right, let's add a switch for the audio. And so now the next time it runs, it's going to be silent. And so let's take a look at the code for this, because it's not too difficult, in my opinion, to make this sort of thing inside of Make Code. So what I'll do is I'm going to head back to, let's go to this Make Code Chrome, and let's open up a new tab. And one thing I really like about Make Code is you can import the program right off of a board. So I'm going to go and double click my, or single click, is it single click? No, double click. Oh, I say it's easy, but now it's going to not cooperate. Let me unplug my other device over here to make sure that's not it. Okay. It's totally misbehaving. Let me unplug it and replug it. The idea is I should be able to pull the UF2 file off of here. Absolutely not. It's totally not cooperating. All right, I won't show you that then. Yeah, it's complicated enough that I won't be able to recreate it immediately on the spot. So let me try unplugging that USB cable and plugging it elsewhere. Absolutely not. Are you seeing, let me see, are you seeing overhead still? No, you're just watching me struggle. Hold on. No, it won't do it. Let's see. I don't know. Yeah, I don't have an easy way to go. Oh, there it seems to maybe have shown up that time. Let's see. It did. All right. Go ahead. Okay, so I'm opening up, I don't know why, it was giving me a ton of trouble trying to get to bootloader mode that time, but it worked, thankfully. So let me take a look here. So this is the UF2 file that was sitting on the board, and now we can open it right up into Make Code. Now I can save it off. Actually, I probably shouldn't have tried that hard on that, because I saved the share URL with myself in a notepad, so that I shouldn't have had to go through that. But there you go. That's how you know it's real. Sorry. Let's take a tour of what the code is doing. So first of all, this is really hacky, and there may be a better way, but what I'm doing is, for the song, I'm just playing it all the time. And then at the beginning of the code, what I'm doing is setting the volume to 0. And then when I start the countdown, I turn the volume up, and when I'm done with the countdown, I turn it off. So Make Code is multi-threaded, so we can do 2 things at once. But the easiest way, there are some start and stop sound blocks that seem to be a little flaky. So I didn't have a lot of success with those. I should be able to start the playing at the same time as the countdown, and I'll work on that and see if I can come up with a more elegant way. But in a bind, this works, which is just let the melody play, and then when you want to listen to it, set the volume up. I'm setting my brightness down to something reasonable. Oh, did someone say the audio went out of sync? Someone tell me in the chat if my audio is out of sync now. Because, no, it was a joke. Okay. Phew. I'm paranoid about that. That's not funny. All right, Andy. Good. I'm glad to hear it's good. Because I find that so distracting to try to watch a video when the audio goes out of sync with the lips. So here's what's happening on start. I'm setting the brightness down to something reasonable. I'm setting my volume to 0 for the reason I mentioned. And then I'm calling this function I made called blink. And I'm sending it the argument 1, which is my color that I want to blink at. And 2 is this is the number of times I want to blink. So let's go and look at that function. I was blinking a couple different times, so I decided to not repeat all these blocks in multiple places, but just create a function for it. So this function called blink has a color and a times argument that come in, and then it repeats the number of times you've told it, so in this case twice. These things, sets the pixels black, pauses 100 milliseconds, and then this is how there might be a better way to do this, but this is how I'm parsing the color call. I didn't know if there was a good way to send an argument of the actual color block, maybe with a hex value. But the way I'm doing it is if the color value is set to 0, we do red. If it's set to anything else, it's green right now. So that blinks. And then after the blink, we go to black. And I'm also setting the sound on variable to true, and that's actually what I'm flipping back and forth with my switch, is whether sound is true or not, and we'll use that to determine if we turn the volume up later. You can see the way I'm activating it. I actually have 2 ways. So for testing, if we look over here in the simulator, when I press the A button, it ramps it up, and then we'll count down my timer. And we can also activate that with the on loud sound. I'll stop this here. So eventually I'll get rid of this because we don't want to be touching things when we use our timer. We want to just use the on loud sound start. There's my switch logic. For left, sound on is false. Right, sound on is true. And then when we do clap, so when you saw this on loud sound, we do 2 things. First, we call this prep countdown function with the number of seconds that we're going to use in the countdown timer. And that prep function will essentially count up the number of pixels that you're going to be using so that you get an idea, oh, it's not just 10 seconds, it's 20 seconds because I loop around twice. And so what I do is for this, I go with an index that goes iterating through this variable called index from 0 to 20, which is the number of seconds. And when we do that, each time we do that, we run this little if-else statement. So if the index is less than 10, then I'm going to set the color at whatever the current index is to blue and pause a little bit. When it gets higher than 10, I'm changing the color. So that way we don't just cycle through twice. You wouldn't be able to see it the second time. We need a new color. And this is when we go around and set them to green. I'm using what is essentially a modulo function here. Set the pixel color at the remainder of the index divided by 10. And so that way there is no number 10, 11, 12, 13, 14 pixel. This strip is only 0 through 9. So this is what loops me back by dividing by 10. So 10 divided by 10 is 1, so we drop back to the first pixel. The next thing that happens after it runs through that function, either when we press the A button or clap our hands, is we call this countdown function. And this is the sort of star of the show here. The countdown function, again, brings in this argument of the number of seconds, when in this case is 20. If the sound on variable is true, then we'll set the volume up. So that's what my little switch takes care of. If not, it won't. And then very similar to the way we count it up, I'm using this index from 0 to the number of seconds. And then I need another, since I'm going backwards, I need another variable which I'm calling the counter. And that is the number of seconds minus the index. So that's what takes us from, instead of counting from 0 to 20, it's essentially going to let us count from 20 back to 0, or 19 back to 0. The logging in here is something I was using just to make sure, because sometimes I need to add 1 to it to make it start at 20 instead of 19, or end at 0 instead of 1. So to keep from going crazy with those, I used this the simulator here, which you can see is just telling me what my counter value is when I hit hit go here, it'll start graphing and printing out. So counter is equal to 19, 18, 17, 16, 15. And since I'm using that modulo math, the 19 is actually the 9th pixel. So that was helpful. I won't need that in the final sketch, but it's very helpful to be able to use that console logging to graph things and look at their values. Then I'm doing the same sort of thing while the counter is greater than 9. We're using magenta, and then when it gets less than that, we set this to blue. So that allows me to go through two sets of colors. At the end of all of that, after it's gone through 20 times with this loop, it sets the pixels to red, turns off the volume, pauses a second, and then I'm calling that blink again and setting all the pixels off. So if we go back to the overhead, this is what your hand washing experience should look like. Off it goes. I have the volume on, but you probably can't hear it. So now I am simulating hand washing. And the idea is this will be stuck with some blue tack over the sink with a little cable running over to the plug with the USB power plug. And I might mount it in one of these just to make it a little more splash proof. But that is this version of the hand washer. So thanks to our daughter for coming up with this idea for our project of the week. And the other version of this I'm going to come up with is going to use the clue, and that'll let us use the, there's a gesture sensor or a proximity sensor here, so instead of sound we can just put our hand near it and it should start. And then I might also take advantage of some of the display that we have on there. Rather than neopixels, we'd be able to use numbers to count down and maybe even include a cute hand washing graphic or something like that. So that is my project of the week, and stay tuned for updates on that. I'll post some videos and a learn guide soon. Before I go, I'll mention again, you can get 10% off at the Adafruit store if you want to use it, although we are not shipping right now, so I'm not sure exactly what's happening with orders. And as we learn more about that, or if anyone in the chat knows what the answer on that is, but I did it. I put up a code, so probably some people will order. I hope that all works out. And as I mentioned, we're also going to be working with DigiKey to help keep our store flowing out to people who want to order. Thank you again so much for stopping by and choosing to spend your time here on John Park's Workshop. And I will see you all next week, so please stay safe out there. See you next time.
Yeah.